Yes. Okay. I first want to start giving you an introduction into the problem we want to address today in the webinar, which is showing a connection to Siemens SIMATIC CFU CIO HART or other SIMATIC periphery. So if you have an asset management application and have a Siemens control installation, like you see down there, where you see a controller and periphery of Siemens, like I said, the CFU CIO HART or the SIMATIC ET200, and they have HART devices attached to the peripheral devices. So, and now the problem you want to show and to address here in the webinar is, so you have an asset management application you're connecting to. And the special thing is that you want to use an FDT-based asset management application like PACTware or Anderson-Hauser Field Care, and not the standard asset management application from Siemens, the PDM. And in the webinar, we will show you the solution, which is bringing these two parts together. So that's a software product called smartLink SWHT, which is connecting on the top side FDT-based asset management applications with the use of a DTM and a hard IP communication protocol to the control network, which is running Profinet, and having the SIMATIC peripheral devices attached, and then establishing the communication from the asset management application over the SmartLink, over Profinet, down to the hard devices and the way back. So that's the problem we address here in this webinar. So as next point, we want to give you some introduction into the SIMATIC CFU CIO HART, and we will switch over to Maximilian.
Thank you, Tom. So also, hello and a warm welcome from my side. My name is Maximilian Holzamer, and I'm the product owner of the Siemens SIMATIC Compact Field Unit portfolio, and I'm happy to have the chance today to present you our new variant, the SIMATIC Compact Field Unit CIO HART. What will be the topics within the next 10 until 15 minutes? Firstly, we will talk about general information and challenges we saw in traditional project execution. Then we will go to the CFU CIO HART part. So on the one hand, I will give you some general information about this product, and on the other hand, I will show you the software side of the CFU CIO HART, so talking about where the CFU CIO HART is integrated in and what can be done with the CFU CIO HART. And last but not least, a just short summary about this topic. But let's start directly with general information, and therefore the first slide I want to use to introduce what is the SIMATIC Compact Field Unit in general. And if I would only have one sentence to describe the SIMATIC Compact Field Unit, I would use the following. It's a smart field distributor direct installed at the process. What does it mean? And I think the picture shows it quite good. What's the meaning of this sentence? If we see here the water tank, we see instrumentation related to the water tank. We could have a measurement about pressure, about level, maybe also about temperature. We could have a flow control, and all this instrumentation things related to the water tank are directly installed at the CFU. You see here marked on the left side. So you have very short field wiring between the instrumentation and the CFU, and the connection to the NOS, to the controller, is done via Profinet from the CFU to the NOS. Also, the pictures on the right side, I think there you can also see the decentralized installation directly installed at the field, quite good. You see here again our CFU, you see here the connection to the NOS, and you see all the instrumentation which is related to the tank will be directly installed to the CFU. When you check about the application areas where the CFU can be placed, you see they are quite different, and this is because everywhere where you could imagine about the decentralized installation, a CFU CIO HART can be placed, and therefore the application areas are quite different. Why developing a new variant? When we decided to develop a new one, we checked what are the challenges we see in traditional projects, and therefore I think also this graph shows it quite good. We see on the left side the effort and on the right side the time, and if we now see the planning of a traditional project, we see of course a certain point of time where the project needs to be handover, and of course this time is fixed and needs to be held. If we now see the real project duration, we see two aspects. The one aspect is we see the highest effort on the last miles in traditional project execution, and on the other hand, due to that fact that we have that high effort, we have a delay. So the scheduled project handover cannot be held, and we see we have a delay, and of course every delay is related to further costs which needs to be avoided. So to summarize, what challenges do we see? The firstly two we already saw in the graph. So at the one hand, no acceptance of delay is the one thing we saw, and on the other side we saw that very much changes in the final phase are there, which is the other challenge. But also we see challenges for project extensions, and we see also challenges for spare part handling. And now of course the questions was, what are the answers to these challenges? And here I just gave the answer to each of this challenge. So if we would eliminate the need for early hardware orders, we wouldn't have that delay and short time to market challenge. This would be the first answer. The second answer, if we would reduce the cost for late changes via late IO configuration, we would also not have the challenge with the very much request in the final phase, which we saw at the graph. On the right side, if we would have a configurable IO concept that decouples software from hardware engineering, then we wouldn't also have that challenge for project extension, because our IO can be defined and even changed during the complete whole project cycle. And same for the spare part handling. Also there, if we would have the configurable IO concept, we would also have easy spare part handling and talking about less spare part inventory. So also there we would have the answer for this challenge. And now the good news is all these answers are given by the CFU CIO HART. So the CFU CIO HART answers all that address challenges that I talked the last sentences about. Of course, now you could ask me the question, how is that possible? And within the next slides, I want to give you also the answers there by talking about the CFU CIO HART. And there I want to start giving you some general information. The first slide is showing our structure of the device. In general, we have two different order options. So we have one CFU, I would say, base device. And secondly, we have a CFU-based device pre-integrated in a housing, as you can see here. If you could remember the sentences of the beginning about the decentralized installation, of course, we have the requirements of a robust installation, and therefore we often have the request that the CFU is pre-integrated in a housing that fulfills the robust environment, and therefore we have a second order option pre-integrated in the housing. The further structure is the following. We have a profile rail, then we have a Profinet interface module. There we talk about two Profinet ports to fulfill Profinet redundancy, so the media redundancy, but also Profinet S2 redundancy. Due to that, we have also the possibility, of course, about configuration and run, so talking about KIA and HARKIA. Next to the interface module, we see our power supply. This is a redundant 24 voltage power supply. And after that, we see our channels to the field, and therefore we have 16 channels that can be connected directly to the field. Now, what is possible with the CFU CIO HART? You see here just the topology as it is. So CFU decentralized in the field, short field wiring to the field devices, and the connection to the rest of the process control system in the north via Profinet. What can now be connected to the CFU? And here I have a further picture which shows it. So you see here our 16 channels of the CFU CIO HART, and each of the 16 channels can be configured if it's an analog input, if it's an analog output, optional both, of course, with HART, if it's a digital output or digital input. So you decide on software side for each of those 16 channels which signal type it is. You don't need any changes on hardware side. So you have on software side the maximum flexibility, since all changes can be configured at each stage of the project. And on the hardware area, you have universal two-wire connection. And also here you see the first answer of the challenges. Due to that, you need also very less spare parts, since only one device is needed for all signal types. So here you directly see the first answer. Talking about spare parts, I have another slide which shows it also quite good. For traditional project execution, so having a look on the right side, you see for every signal type, a separate signal type specific module is needed. So we need a digital input spare part module if it's needed, a digital output spare part module if it's needed, an analog input spare part module if it's needed, and an analog output spare part module if it's needed. If we now have a look to the CFU CIO HART, and we have here this example that 10 channels are already used, we would have 6 channels left. So talking about our 16 channels, and all of those 6 channels are left for extensions and are available for each signal type. So we don't need this signal type specific module, because we have one device for all those signal types. Also here, we see it again. So we don't have any change on hardware side. It's really just on software design, where it's decided which signal type each channel will be, one device for all those signal types. I now mentioned the topic for the CFU CIO HART. The CFU CIO HART is available since nearly 1 year, giving you also an outlook in the future. For 2026, we also plan the same module for our ET200 SPHA. So with the same functionalities it is now already given for the CFU CIO HART, we will have a configurable module for the ET200 SPHA, where all those signal types, as I mentioned before, can be also configured on software side. With this said, I go through the software integration. Where is our CFU CIO HART integrated in? And also there I have good news for you. You see here just a graphical overview. We are integrated in all usual Siemens PC7 and Siemens engineering systems, but also planning and design tools. So talking about Roneta, talking about the concept and design tool, or also the tier selection tool for planning, and for engineering we are integrated in PC7, in tier, and also classical step 7, and it is planned to be also integrated for the future in our new control system PCS Neo. Also here the information, the third-party integration of our CFU is also possible. Therefore, you will find on our website a GSDML available where you can integrate the CFU in a third-party system. Now, how is the software configurable topic be implemented in engineering? And here I made a screenshot for our PC7 and tier view. And the handling is the same. So when the CFU CIO HART is placed in the engineering, you see you have 16 channels available. Also on tier side, there are 16 channels available, and then you have the possibility via drag and drop to decide for each channel which signal type it will be. So you can decide all of those signal types, and just per drag and drop to each channel, you define which signal type it will be. With this said, just a short summary about the last 10 minutes, what I said. We have two variants, so talking about a variant within the housing and also a variant with just the base device. The structure is we have two Profinet ports, have the redundant power supply, and then have 16 channels which are freely configurable. We, of course, fulfill the highest robustness due to the decentralized installation. So talking about -40° until 70°, and also the conformal cording. Here again, we are integrated in engineering system, but also talking about network and design tools. With this said, I want to say thank you very much for your attention about the CFU CIO HART part. And now I hand over again to Tom, and looking forward to the presentation where the two worlds came together. Thank you very much.
So an introduction into the SmartLink SWHT product. You have seen the topology on the left side already before. So now it's a little bit more general because our SmartLink product supports several controllers and remote IOs. So where you can connect asset management application to, so that's controllers, remote IOs from Allen Bradley, Siemens, Schneider Electric, Arstahl, and Turk. So here, let me try again the spotlight. Here you see the possibilities. So a SmartLink has to be attached to the network where you have the Profinet, the Ethernet IP communication. It is always independent from the controller. You see here, like Max shown before with the engineering, we have a second path to the communication network, to the Profinet, which allows them to connect the asset management application directly to the remote IOs or the CFU, and so independent from the controllers. So for Siemens controllers, that means so you can have any controllers installed, starting from old S7300 to S7400, and the newest ones, of course, the S71500s in the Profinet network. For other control vendors, we have optional routing through the controller, so that's available for Allen Bradley and Schneider Electric. For Siemens, we don't support that routing, so the SmartLink SWHT has to be connected directly to the Profinet network. The integration of the asset management application is without interference into the operational installation, so into your control process. So with the SmartLink SWHT, you connect to the Profinet network, and the SmartLink will then establish an additional communication to the CFU or the remote IO devices, and use this additional communication path then to communicate with the HART devices. There's no restriction on which kind of HART communication, which kind of HART comments could be sent from the asset management application, because for the communication, the SmartLink SWHT is using the HART IP protocol. So that's a variant of the HART protocol, which is running on a standard Ethernet TCP/IP stack. And so therefore, the asset management application decides, okay, which commands it has to send to the HART devices, and the HART devices will get exactly these commands then being sent via HART from the CFU or the remote IOs. So to summarize, the handled tasks is quite precise and defined tasks the SmartLink SWHT is fulfilling. So the first thing is so that on startup, it scans all configured hard modules for the attached hard devices and creates a live list of all the devices connected. We will see later on, okay, what you have to configure. Then, if it has this live list established, it waits for incoming hard IP commands from the asset management application, and then is transferring these commands according to the configuration to the right, let's say, the right tunneling protocol for the controller. So in the Siemens case here, it uses that hard IP information and encapsulates it into a Profinet communication to the CFU or the ET200 devices. Then it sends this hard request to the device, waits for the answer then from the hard device, which is then provided via the remote IO, and then of course sending that back to the asset management application. So in summary, it really creates an communication channel which allows on the top side to have hard IP, so and on the lower side to have hard requests. So and everything in between is transparent for the applications or the hard devices. Of course, you know, hard is not the fastest communication. It's very important so that the SmartLink SWHT is doing an optimized scheduling so to reach the best communication performance. So the SmartLink SWHT tries to do as much as possible in parallel, because then we are using, let's say, the bandwidth of the Ethernet communication we have on the top side best, and try to have as much as possible hard communication requests then out in parallel and get it back from the different devices. If you now look what we are supporting on Siemens periphery devices, so first, of course, the topic of the webinar today. So we support the SIMATIC CFU CIO HART. There, of course, if you have configured the channel to the hard analog input or the hard analog output, then you can use the SmartLink SWHT to connect to the hard device, which is attached to the channel. We are also supporting different variants of the ET200 Remote IO. So that's the ET200 SP, the ET200 ISP, the ET200 SPHA, which Max mentioned before also in the presentation, and the older ET200M. And together with this periphery, we support also a large number of different I/O modules you can plug into the ET200s. Also, here, since we have several options of redundancy in the Siemens peripheral devices, we are supporting both interface and module redundancy. These both redundancy types you have on the ET200 SP HA, but we also, for example, support the interface redundancy on the ET200 ISP. Okay, now short look onto the configuration. I will keep that quite short because later in the presentation we will have some demonstration where you will also see these configuration pages again. But the important thing to mention here is that the configuration is really simple. So what you have to provide are two informations. So you have to provide the IP address of the remote IO or the CFU, and you have to provide for the ET200s the slots which are used with hard IO modules. Of course, if you have redundancy features like you see on the screenshot below with the ET200 SPHA, you have then to provide information about the redundant pair. For example, if it's interface redundancy, you have to provide the IP address of the redundant interface. For the module redundancy you see here, it's enough to specify if IO module is redundant or not, and the rest is done with then let's say the rules implemented in the SmartLink. Besides the configuration, the web UI of the smartLink is giving you some diagnosis capabilities. As you see here, that's the live list I mentioned before. So that allows you to see, okay, could smartLink establish connection to all remote IOs configured, and within the remote or with the remote IOs, which hard devices are attached, and to which hard devices the smartLink SWHT is able to establish a communication. From the hard device, as you see here, you get then some additional device information like the vendor, the type, or some revisions. The topic of today is, of course, using FDT to connect to the hard devices using the smartLink SWHT. What we provide together with the smartLink SWHT software is communication DTM, which is using hard IP to connect to the smartLink, and that is then the path which, or the components which have to be integrated into the FDT application, and that's then be used to establish the hard IP communication to the smartLink. So you have two steps here in the FDT communication. The smartLink SWHT is delivered or is built as a Linux Docker container, so which could be downloaded from Docker Hub or the SoftLink web pages. We also provide a virtual machine image, so for easier use of the application on a Windows machine. So there you can use our Hyper-V image and simply run that on an existing Windows machine in parallel, for example, to an FDT application. As mentioned before, additionally, we provide the smartLink communication DTM for all FDT-based asset management applications. Okay, to summarize here, the benefits you have with our smartLink SWHT product is that you can use a central asset management application with hard devices which are connected to Ethernet controllers or remote IOs. So that's one of the main goals, so that we are allowing the customers using the product to really have a central asset management where you can collect all the information about the devices installed in the plant in one central place. It is deployable during live plant operations. You don't have to program something on the controllers. You don't even have to shut down the control communication. You can install it in addition by connecting our smartLink SWHT to the Profinet communication segments. It's independent from the existing controllers, so we don't use controllers to do the communication. The communication is really done directly with the remote IOs, with the CFU to the hard devices. If you compare it with other solutions which are typically using hard multiplexers, the big advantage is with our solution, you don't need additional hardware. So you're using the existing infrastructure to get access to the hard devices, and you don't have additional costs for hard multiplexer, hardware, and cabling. We have a scalable license model, which in principle says, so you only have to pay for the number of hard devices you want to access. So that's scaling with the number of devices, and so you get license for a certain number of devices you want to integrate into the FDT application. So we test the smartLink with different asset management applications like you see down below. As said, we have PACTware, we have Anderson Hauser Field Care, but of course we also test it with non-FDT application, like for example the Emerson EMS Device Manager. Okay, now let me switch over to a live demo. So the demo, I must say, is not totally live. It's a screen capture of a demo I did on our demo system to make it a little bit easier for the webinar today and to provide this information. But I will play that video and say some words to it. So what you can see here is our demo systems. I now opened the web interface of the smartLink SWHT. You see here it is a web interface you can open in any browser. You have to log in, and then you have access to the web interface. It's a quite simple interface. You see here to configure the smartLink, you have to open here this HART Remote IO page. In this demo, we have two Remote IOs being configured. One is an Allen Bradley Remote IO, and the other one is a Siemens ET200 SP Remote IO, both with one IO module and one device attached to the IO modules. That's something you can see now here on the diagnosis page. So you see the communication to all the remote IO and to the IO modules are existing, and we have two devices, one from PR Electronics and one from Krone attached to it. If you now go and start PACTware, so you see here in the demo the version 6.2 of PACTware. Here, first to show you the communication with the PACTware DC version, which is a simplified user interface. Here, we did a configuration before, and if you've done that once, so you simply have to click, and now the PACTware is doing the communication already via smartLink to the HART devices. You see here it has found the two devices we've seen, like the which is available on the Siemens PLC, and you see here if we are going to the measured values, we already have temperature values which are coming in, and you see here the PV is changing. So that's updating every second here. Okay. As next, shutting down the PACTware DC, I want to give a little bit more intro in what you have to configure. That's now done with standard PACTware, not using one of the saved projects, so creating a new project. And you see the first thing you have to do is with the new project, you have to select the communication DTM you want to use. In that case, it's the SmartLink SWHT HART, which is added to the project, and then the parameters of this communication DTM has to be inserted. In that case, it's only the IP address of the SmartLink and the web user credentials. So we use here the web user credentials to really simplify the configuration of the DTM. So because with these credentials, all the configured devices and remote IOs are downloaded from the web interface. That's what we see here in the next step. So when we see here, we can here read the configuration from the device. You see here it's the two HART devices we have seen, and now with a touch scan, the FDT application is going online, scans the channels, and if that's finished, you see, okay, we will have found the two devices again in topology scan. It is what we see here is a standard installation of PACTware. So therefore, we are using the generic HART DTM because there's no special device DTMs for the devices installed here. And if they are selected, that's then okay. And you see here on the left side again the two devices which have been found. If I now establish a connection to the Krone device, we are at the point we have seen already before that now can open the generic device DTM and again read values from the device, as you see here again, then the PV values for the current temperature. Okay, as said, a very short demo of our product working together with the Siemens ET200 SP. We have also additional information about smartLink and our asset management solutions available. So on the one side, information of our webinar series, you can find at the link you see here. We have additionally a solution page on our web pages, which is giving you an overview of all our software solutions for digital plant asset management, and of course different products. The one we had look today is the smartLink SWHT, but we also have smartLink solutions for Profinet and Profibus devices you can see below with the smartLink HWPN and the smartLink HWVP. Okay, thank you for your attention. Now we are coming to the Q&A part of our webinar.
Yeah, thanks, Tom. And thank you, Maximilian, for all the information and knowledge up to now. I have one question here in which it's being asked: in which X zone can the CFU CIO HART be installed? This goes out to Maximilian.
Yes, the CFU CIO HART can be installed directly up to X zone 2. So can be installed up to X zone 2 and can be used there. This is the requirement we also had due to the decentralized installation, and is fulfilled. We can be installed up to X zone 2.
Okay, perfect. I'm kind of looking, but since there are no questions right now, I also want to point out that our next webinar is going to be on the 17th of June. It's going to be about unlocking HART devices for data efficiency with a focus on the oil and gas industry. So do look us up on the SoftLink website and to get further webinars in relation to topics of your interest. For the moment, I'm just going to say thank you for your attention. Thank you, Maximilian, for your support in this webinar, for all your input. Very much appreciated. And thank you, Thomas. And thank you to everyone who attended. Have a good week, and hopefully till next time.